See one definition which is useful here. Lewis base. Simple definition: electron pair donor. Electron pair donor is called as Lewis base. Amines act as Lewis bases, right? Because the nitrogen contains lone pair. So amines donate that lone pair. Okay. But here I'll change the definition. In the physical chemistry, first year physical chemistry, Lewis base means electron pair donor. But coming to the amines basic nature, one special word will come. Look at this, the special word. It is the tendency of nitrogen atom to donate its pair of electrons to proton. That is very, very important. The tendency of nitrogen atom to donate a pair of electrons to proton. That is very, very important. Clear? So you can write the definition. Basic nature of amines. Basic nature. Here also lone pair donation takes place, but particular. But both are same only. But this is the sequence, okay? Follow that. Basic nature. It is the tendency. Tendency of nitrogen atom to donates its pair of electrons to proton. General statement. Before starting general statement, look at this concept. If nitrogen is connected to electron donating group and if it is connected to electron withdrawing group, two cases. Electron donating group donates electrons, okay? Then what happens to the density, electron density on the nitrogen atom? Electron density increases. Small size nitrogen cannot hold more electrons on it, so it readily loses electrons to proton or donates electrons to protons. What happens when donating group is present? Donating group supply electrons to the nitrogen atom. Already nitrogen is having 2 electrons on it and more electrons are coming. So what happens to the electron density? Electron density increases, and small size nitrogen cannot bear more electrons on it, so readily donates to H plus proton. That is one concept. In the minus I group concept, see, withdrawing group withdraw electron pair present on the nitrogen atom, right? So how can it donates? Donation is not possible when withdrawing group is present, because withdrawing group takes all the electrons, right? So if minus I group is present, basic nature decreases, donating power decreases, donating nature decreases. Very simple. Plus I groups increase basic nature, minus I groups decrease basic nature. Simple concept. This is the reason when plus I groups are present, electron density over nitrogen increases and it donates electrons. Clear? Electron withdrawing groups withdraw electrons from the nitrogen atom, so it unable to donate pair of electrons. So can we write some generalized statements? Tell me that statements. Plus I plus I groups increase basic nature, minus I groups decrease basic nature. This is generalized statement, okay? అద్వైతం అక్కడ కూర్చొని ఎక్కువ క్లియర్గా కనపడుతుంది. Okay. See, basic nature concept is different from that of acidic nature. For acidic nature, what we will check? Tell me. For acidic nature, what we will check? For acidic nature, if minus I is present, acidic nature increases. If plus I is present, acidic nature decreases. But while predicting basic nature, you should follow some steps or rules. Clear? Follow these 3 steps while comparing the basic nature for a given set of compounds. Follow these 3 rules, then it will be very easy to you. Basic information is plus I increase basic nature, minus I decrease basic nature, right? Now let us start the 3 important steps. Step 1 or rule 1, anything we can consider it as a step 1 or rule 1. While comparing the basic nature, first see the hybridization, or check the hybridization. See, first step, check hybridization. Check hybridization of what? Hybridization of nitrogen. Hybridization of nitrogen. sp3 hybridized nitrogen is more basic than sp2 hybridized nitrogen. sp2 hybridized nitrogen is more basic than sp hybridized nitrogen. Right? How to identify sp3 hybridized nitrogen? sp3 hybridized nitrogen. How to identify sp3 hybridized nitrogen? How to identify sp2, sp? Yes. See, if nitrogen is surrounded by single bonds, if all are single bonds around nitrogen, that is called as sp3 hybridized nitrogen. If nitrogen is surrounded by one double bond, then it is called as sp2 hybridized nitrogen. If nitrogen is attached to triple bond, that is sp hybridized nitrogen. First step, you have to check this only. Check the hybridization. This is the correct method of predicting basic nature. Okay. Check the hybridization of nitrogen. Which nitrogen is more basic nitrogen? sp3 hybridized nitrogen is more basic. Clear? Let us see one example. We have 3 compounds. Which is more basic? A. Because nitrogen is surrounded by single bond. Single bonded nitrogen, sp3 nitrogen. So more basic. This is basicity order. Double bonded nitrogen. And this is triple bonded nitrogen. Triple bonded nitrogen, sp nitrogen. You know, this is sp3 hybridized nitrogen, sp2 hybridized nitrogen, and sp hybridized nitrogen. So basicity order will be A greater than, B greater than, C, A, B, C. So after getting the question on the basic nature, first check hybridizations. Why sp hybridized nitrogen is less basic? Tell me. Why sp hybridized nitrogen is less basic? Okay, I only will. different answers are given by you. You tell me, what is electronegativity definition? What is the definition of electronegativity? It is the tendency to withdraw electrons. Electronegative atom. Fluorine is electronegative. Oxygen is electronegative. Nitrogen is electronegative. And if we see the hybridization sp, percentage of S character 50, percentage of P character 50. If percentage of S character is more, then its electronegativity nature will be more. So this is more electronegative nitrogen. Triple bond nitrogen is more electronegative. It never donates electrons. It always try to withdraw electrons only. But you no need to learn that reason. Just remember the order. Clear? If you get any question, then answer will be triple bonded nitrogen is more electronegative nitrogen because percentage of S character will be more. Clear? So C is less basic than B. B is less basic than A. Right? One cyclic example for this. One cyclic example. Very easy question. First of all, check hybridization. Double bonded nitrogen sp2, single bonded nitrogen sp3. So order is B greater than E, B greater than A based on hybridization. Okay. More application part. We go with the application part rather than theory. Right. Okay. First condition or rule is checking hybridization. If hybridization is same, for example, in two compounds, hybridization is same, sp3 or sp2, then check degree of amines. Yesterday I given about degree, right? Right. Second rule, rule 2. Degree of amines. If hybridization is same, check degree if hybridization is same. What we have to consider? Degree. When we have to consider degree? If hybridization is same. Clear? Right. One simple example. Single bonded nitrogen only, no? There is no double bond, there is no triple bond. sp3. This is also single bonded nitrogen only. But what about degree? To this nitrogen, one R group is attached. So this is primary. To this nitrogen, two R groups are attached. This side one R group and this side one R group. Two R groups. So this is secondary amine. For this left side only one R. This is total R. Only one R primary. So which degree amine is more basic? 2 degree amine is more basic. General order is 3 degree amines are more basic than 2 degree amines. 2 degree amines are more basic than 1 degree. According to this order, generalized order, answer will be B greater than A. B greater than A. If degree hybridization is same, degree also same, then see cyclic or open chain amine. Okay. Next rule. Rule 3. If hybridization is same and degree also same, once look at this. A and B. What is first point? Hybridization. Single bonded nitrogen only, na? So sp3 hybridized. This is also sp3 hybridized. What about degree? This nitrogen is surrounded by how many bonds? 1, 2, 3 bonds. This nitrogen is surrounded by 1, 2, 3 bonds. 3 degree. Hybridization is same, degree also same, but one is open chain amine, one is cyclic amine. Which amine is more basic? cyclic amines are more basic. Cyclic amines are more basic than open chain amines. Open chain. So A greater than B. Cyclic amines are more basic than open chain amines. See, like acidic nature concept, Ka, pKa. Here also we have Kb, pKb. What is Kb? What is Kb? Base dissociation constant. Base dissociation constant. It is represented as Kb, base dissociation constant. Okay. Look at this. RNH3 positive. This is the reaction represents the basic nature of amines. Nitrogen is giving its lone pair, right? If any atom donates its lone pair, then it will get a positive charge. Positive charge, right? If you write a equilibrium constant like a Kb, how to write a product concentration by reactants concentration? RNH3 positive divided by RNH2 and H plus. This is not mandatory, just I am giving equilibrium reaction for the reaction which represents the basic nature of amines, right? Now, coming to the most important relation, if Kb value for a particular amine is more, then it will be more basic amine. Clear? So we can write relation Kb is directly proportional to basic nature. pKb is inversely proportional to basic nature. Let us consider its dissociation, base dissociation as Kb1, Kb2 and Kb3. Okay. Greater than or less than? Which is 3 degree amine here? Second one is 3 degree amine. Let us expand the structure. Nitrogen surrounded by how many methyl groups? 3 methyl groups. 3 degree amine. This is 2 degree amine. This is 1 degree amine. So answer will be B greater than C. C greater than A. And Kb order? Kb2 is greater than Kb3 is greater than Kb1. pKb is reverse. pKb is reverse. After nomenclature, immediately we have to discuss basic nature because we won't get later. Basic nature purely depends on the nomenclature only. Okay, that's why immediately we have to start basic nature. Next. Do the second question. A, B, C, D. Identify more basic. D greater. D more basic. D, A, B, C. Sure. T is more basic. Why? 4 methyl groups are present. See, expand the structure. DABC, you also do ABC, online students also. Nitrogen is surrounded by how many groups? 4. But nitrogen valency is, general valency is 3 only. If nitrogen is surrounded by 4 groups, then it gets a positive charge. There is no lone pair on the nitrogen atom. Lone pair is not present on the nitrogen atom. So, it do not act as a base. Clear? Where is lone pair on the nitrogen? What is definition of basic nature of amines? It is the tendency to donate a pair of electrons to proton. Where is lone pair? If nitrogen is surrounded by 4 bonds, it will get positive charge, remember. Okay? Now this is least basic compared to all. And CH3NH2, it is a plus I group. See, this is also having plus I, but one minus I is attached. So after that this will come. Okay, some plus I is there, plus I part and as well as some minus I part also there. That's why next basic nature will be C and next D. So first A, then C, A, C, B, D. Last one is D. Remember this example. This is electron donating group, na? CH3. No, inductive effect is less compared to resonance. Inductive effect is just, it is a partial displacement, not complete. Okay. Resonance involves complete shifting. Completed. Now one question based on the nomenclature. Shall I clear this, online students? Identify the more basic amine. Identify the more basic amine. Identify the more basic amine. N-methyl ethanamine, N-methyl ethanamine, N-N dimethyl butanamine, two pentanamine, D ammonia. Very easy question. If you know the structures, then you can answer. Yesterday I given nomenclature. Which is the answer?
D.
Answer is undoubtedly B only. N-N dimethyl butanamine. N-N dimethyl butanamine. Look at this. 1, 2, 3, 4. N, N dimethyl butanamine. This comes under which degree? Pentanamine వచ్చిందా? Pentanamine. Yeah. This is 3 degree. N-methyl ethanamine is which degree amine? N-methyl ethanamine. 2 degree. 3 degree. 1 degree. and ammonia. Ammonia is least. There is no plus sign. But the question is identify the more basic. B is the answer. More Kb value? This one only. Least pKb? That one only. Correct only, na? More Kb? Least pKb. This is more basic. So, more Kb. It contains more Kb and least pKb. Least pKb. Inductive effect based concept, plus I minus I, and resonance based basic nature also there. Resonance based. Let us do some resonance based questions. Resonance based. Okay. In generally, plus some groups increase basic nature. Minus some groups decrease basic nature. What is its name? Benzene with NH2 is called as aniline. Aniline. For aniline, attach one NO2, one methyl, and one is plain. A, B, C. First of all, write the effects. Write the effects. Minus M group. Minus M group. Plus M and neutral. Plus some groups increase basic nature, so B will be more basic than C. C will be more basic than A. A is least. Why? Basic question. Can you try? Identify the amine with more basic nature. B greater. B is more basic. More basic amine is B. B is more basic. Why? A is a resonance in it. So A is more basic, right? Who said A? Adiba, you only. Adiba? What is the definition of basic nature of amines? It is the tendency of nitrogen atom to donate its pair of electrons. Now let us consider hydrogen is waiting to get electrons from these three compounds. It is waiting which nitrogen atom will give electrons to it. It is ready to beg the electrons. Okay? Which nitrogen is a good donor? Right? See this. Everyone knows about structural requirement for resonance. If double bond is present adjacent to an atom and that atom contains lone pair, then resonance is present. This lone pair participate in resonance. Here lone pair is not available for the donation. It is busy in resonance. Then how nitrogen donates its pair of electrons? Clear? This is least. Why? Nitrogen lone pair is participating in the resonance. How it donates? Clear? Least basic. Now coming to this. What about its degree? It is primary amine or secondary amine? Primary amine. It is secondary amine. So this is more basic. Simple logic. Secondary amine primary amine. Here resonance decreases basic nature. Okay. Nitrogen lone pair participate in resonance. So unavailable for the donation. So least basic compared to 1. If more is the resonance, for example, if that side also, if another pi band is present, then very less basic. Write the reason also. Nitrogen lone pair participate in resonance, so unavailable for the donation. Just tell me. Basic nature. Clear?